So hello for today. I have a couple tips for CNC machining, and it could be useful for some projects, and it could be very useless pretty much for some stuff. For example, things like these like logos. It's very not helpful, but for example, small pieces. Sometimes these pieces, when you are machining, they are gonna fall inside these liners, and it's gonna go inside the buckets, and then you have sort of drawers. You can uh, pull them and collect the pieces. But one problem with that is these sparks are gonna hit the piece after, like, for example, this is done uh, machining, and it's gonna fall, and the sparks are gonna hit it, and you have to clean it with grinder or any other tool, and that's gonna take time, and it's tiring. But there's one way to avoid that, and that's with microjoint. And depending on the machine that you're using, most of them have uh, a little computer. I mean, pretty much all of them have this computer that there's a program. You can do all sort of things with it, and microjoint is one of them. But I prefer doing it inside AutoCAD while nesting, because this microjoint could be here, and which is not good, because this is supposed to be a smooth circle, and if it's gonna start machining from here, that's not gonna be a smooth circle, and then you have to add a lead in, which the lead in is gonna look like this. But I still prefer the microjoint to be like this from experience, at least for the type of work I do. I work at a military uh, armored vehicle factory. Sorry, I made that a bit longer than I should. Uh, but for example, this is door hinges, and these are two different types of door hinges, and I do microjoint in these flat areas that is supposed to be just stoppers for the hinges, and it doesn't have to be a perfectly smooth surface, and it's not going to show. These parts are going to show, and they're supposed to be smooth. Uh, and I find this microjoint very helpful, because later you can just smash this whole piece to the ground, or hammer the pieces, or just easily let them loose. And this gap depends on the nozzle you're using and the speed. But for example, the nozzle I'm using is 1.8, and 2.0 is gonna be uh, like a mid ground. uh, if it's like, for example, uh, uh, if it's, for example, like 3 millimeters, it's gonna be hard to take the piece off, and if it's 1 millimeter, it's usually just gonna fall off while machining, and we don't really want that. We're trying to avoid that, and for like really small pieces like this, it's really helpful, because, as I said, the sparks are gonna get on the pieces, and you have to clean them later, and it's a pain in the butt to do so. Uh, yeah, I find this micro joint very helpful, and one thing that's really great is sometimes the drawers are gonna have a lot of iron filing and iron dust, and uh, it's hard to pick up, or find your pieces inside there. So if the pieces are on top of the table, it's much easier to work with. Uh, But there's one other way, which is like joining the pieces together with uh, a little bit of ironing left, like this. For example, this piece is this is good for uh, pieces that's like a little bit bigger, because if I have micro joint here, then I have to do another square afterwards. So this piece is gonna come off, because if you don't do it, like, if you leave this, and let's just demonstrate that real quick. For example, usually the plates that I'm working with is 1500 millimeters by 3000, and if I leave this piece here and the plating, and we do a little bit of machining, Later we have to, my apologies, I should have prepared for this. Later I have to do a square afterwards, so I can give this square to the people working with these pieces, because it's not going to come off from the rest of the plate, and we don't want to take the whole plate to the person that's working with. And sometimes that's not very helpful for big pieces like this. This piece is much bigger than that, not very big, but much bigger than that, and for that I use the pieces to be joined, and that way this piece is not going to fall off or damage the machine. Sometimes if the uh, if the piece is in a horizontal x-axis, it's gonna get between the liners, and it's gonna damage the machining head, and that's also not a good thing to happen. So I use these two methods in my daily work, and I find it very helpful, and saves a lot of time. I hope you found this helpful. Uh, and one thing before I close this video, uh, it doesn't have to be a perfectly square uh, machining. For example, sometimes it can be just a very bizarre shape. For example, I have this empty space, and I can just have this sort of, not the best example, but yeah, I can do like a simple silhouette for this, and later give this as a piece to the person working with it, and they can use that. So yeah, that's also an idea to work with. Thanks for watching this video. Hope you found it helpful. From my experience, it works great. Yeah, peace.